Welcome to our presentation, everyone. My name is Abhilash Ramesh, and these are my teammates.
Hi, I'm Akila Podpugandi.
Hi, I'm Prasuna Mitikiri.
Thank you very much, and welcome to our presentation of our project, which is the implementation of an anomalous query detection system in PostgreSQL. In this video, you are going to see what we have done in the past 3 months, right? So in this table of contents, we are showcasing the introduction. So we are going to talk about what are the different types of attacks that we are trying to cover. What is the basic idea? Why did we, why do we have a need for this topic in general? The second slide is going to be why are there DBMS anomaly detection systems? The third slide is going to explain about the different methods of how the anomaly system is developed, or the underlying architecture of the anomaly system, different anomaly systems. The fourth slide is going to explain the architecture of our anomaly system, the one that we have created over here. The fifth one is going to be the modeling phase, the model training phase, where we talk about how we have trained the model and how we have validated about our how we have validated our models accuracy and all the other terms and terminologies. And the fifth slide is going to be about our testing phase. So we are going to talk about what we have used for testing, what metrics we have used in general. The sixth slide is going to be about what we are looking forward to doing in the future. So, in the past 30 years, we have seen a huge development or a huge jump into technology, or companies embracing or accepting technology into their systems in general. So, with a lot of acceptance of a new culture comes a lot of stigma or a lot of issues in general. So, when people accepted technologies, they saw a rise of a different kind of crime, which is known as cyber crimes. So, people who did cyber crimes mainly used the vulnerabilities of the internet or the system to attack for the data, to take data, replace data, or even delete data, which is a huge issue when a company is completely digitized. I mean, your records are all digital, everything is digital, and then one day somebody comes and replaces them. Poof, you have a huge problem in your hand, which is not good. So, once people started to realize that there was this kind of attacks, what they did was they segregated the attackers broadly into two main types. So one type was known as outsider attacks, where the person accesses the system or the database from an external network. So the person is trying to break into the network inside the company, and they are trying to break into the firewall. They are trying to get authenticated as somebody. But then, you know what? The company can place one or two more firewalls and have an authentication system which cannot be fooled. All right, which makes it much more easier to avoid such attackers. The second type of attackers, on the other hand, are much harder to avoid because they are your own employees. So your own employees are the attackers, which means A, they are harder to detect because B, they hold the power of authentication, and C, if they attack, they can go untraceable. Okay, so your employees are accessing data, they are doing all the work, your employees are doing their work, that's it. So there is no suspicion until and unless some important or valuable piece of information is lost, which is a huge loss for a company, any company in general. These kind of attacks, which are so hard to prevent, are the ones we are going to focus right now. So for preventing such attacks, what do we do? So we have created, they have been proposing systems which detect such anomalous or such abnormal requests inside the system, which is where we get the name anomaly detectors. Anomaly is anything which is not normal. So anybody who is requesting for an unusual query data or unusual query request or unusual data can be termed an anomalous query or anomalous request. So in our modern day storages, such as that is DBMS or databases, um, we have been proposing database anomaly detectors for from 1990s. With such proposals and a huge amount of development of new data systems, we have been successful in developing different types of systems that can be used or that can be used to detect anomalous queries in general. So, how do we extract the queries or the features for training our model in general? So, for extracting the features from our queries, we have mainly developed two techniques, or we rely on two techniques. The first one is data centric, and the second one is syntax centric. Now, for the first one, the data centric technique, we rely on collecting the data that is going to be obtained by executing the query. So, the system tries to predict or tries to construct a tree of what tables are going to be accessed by by the query. And once we find out what kind of tables are going to be accessed by the system maps a tree and sees if the user is accessing any of the tables that are not supposed to be accessed by that particular user. All right. This system may be efficient, but it is computationally very expensive, which makes it a less ideal candidate for places where there is not much protection required. So, for places where the system needs to be pretty lightweight, they can implement something called as a syntax centric feature extraction technique, where the syntax of the SQL query provides the features for our model to be trained. Basically, what we do is we take an SQL query, look at the syntax, we look into what kind of SQL query command is being executed, what tables are being selected, what columns of the tables are being selected, and then we create a one hot encoded row to showcase our features. Once these features have been created, what we do is we give that to the model. So we have selected the syntax-centric advanced anomaly detection system because it is lightweight. It can be used for most businesses which want a very moderate amount of protection from anomalous queries, and it can take on like user input. So, for example, if an administrator has a kind of set of queries that are legit or legitimate, he or she can feed that query into the system, and the system will take these queries and say, these are my benchmarks. Now I have to compare the others to find out if they are similar to this query for this role or not. And that gives the user a bit more of flexibility in trying to understand. If somebody is promoted, he can say that this way, hey, you know what, this user is promoted, so he or she is allowed to access these set of tables. And the best part about the syntax centric anomaly detection system is that it is comparatively easier to implement than the data centric system. So the data centric extraction technique involves creating trees, which takes a lot of time and a lot of computational power. Meanwhile, the syntax centric it takes only parses or gets the syntax or the features from the SQL query itself, which makes it much more easier to implement.
Hey, this is our this is the architecture of our anomaly detector system, and our architecture is compressed of several components and phases. We have actually mainly have two phases: training phase and the detection phase. In the training phase, we have like actually collected the log history, and we have then again pre-processed the data. So why we need to pre-process is like the collected data will be consist of unnecessary information, so we would like to improve the performance. So that is why we are like trying to do pre-process we are trying to pre-process the data by like extracting the feature using syntactic based method, which Vilas has mentioned earlier. So that information based on that information, model is going to create user profiles. And this is in the detection phase. Anomaly detector is the main component of this phase, which actually detects if the user query is anomalous or not. So whenever the user requests for a query, it passes through the parser and it compresses the query into, like, it optimizes the query, and then the optimized information will be data will be passed to the pickle model. This pickle model actually consists of the developed model. So we have like the models which we have developed in the training phase. Those models will be stored in the pickle model. So then that model extract the information from the parser, and then it will predict the roles. At the same time, anomaly detector collects the actual role of the user, and then it will match with the predicted role. If there is a match, then it will give the positive result. Otherwise, it will send an alarm to the administrator. So this is like just basic outlayer of the architecture. Akila is going to explain further in detail about these components.
For building our model, we are taking the data from log CSVs. As we already know, we have to log all our queries which are being executed on a PostgreSQL system. To get it logged, we actually have to configure some files in Postgres system. So there is a file called PostgreSQL configuration file in the Postgres system. So where we customized it and modified it in such a way that it has to be saved in all logs, all query logs in a CSV log. And like we also give in specific in a specific format, and what statements has to be logged, and all the information we have given in Postgres configuration. After once we have modified this file, we have to restart the system, Postgres system, then only it will start logging, then only it will start affecting. After we created a synthetic data with simple queries like select, insert, delete, and update the queries. So these query information will be like with with only one table, not with any where clauses or with any complex queries. We just took a very simple query so that it will be easy for the initial phase to get it passed. So all this information, all the log information, specifically like which user has executed what queries and what time, all this information will be saved in this log CSV files. We will be obviously this log information will consist of a lot of information which is totally not necessary for building a model. So we have done some cleaning part, processing steps, and then we feed it to the model. Next. So the log information that we have actually created some synthetic data, as I already mentioned. We have taken sample 3 users. Our database system is not a role based system, so we are treating our users as our roles. So we created some set of queries for each user. Like we got it around like 2,445. Sorry, 2045 rows. I mean the sense queries. Like in this log, all these queries got logged in the log CSV file with the 23 columns, which is having a lot of information like what date it got, date and time it got executed, and which user, the user information, and from which application, and what is the query and what is the command type, and whether if the query is executed successfully or not, and whether if it is logged is as a log or with error or any debug. Like a lot of information will be saved in this logs history. So in the cleaning phase, we did a lot of cleaning to remove all this unnecessary information which is not required for modeling, and then we reduced it to the 7 columns. And then in the pre-processing parsing step, we as Abhilash already explained in his initial steps, like what are the feature extracting steps we have taken. So in this we have taken only the query parsing syntax feature extracting techniques, where we pass the query to get information like what is the command type and what are the columns that are being accessed in that particular query and what are the tables and all. So we also deleted, I mean, removed all the duplicated information, like duplicated queries which are being executed again and again, which is totally not necessary for building a model. So finally, after cleaning all this data, we got total 1,123 rows with 4 columns, which consist of username, which is our target variable, and which is the one we are treating as our role, and then the table and the query information, which is passed to give an features like tables, columns, and the command type that are being used in that particular query and by that particular user. So this is our representation of our data, like before feeding into the model. Next. So, as I already told, here our target variable is our user information, like our user role. So, we this is a categorical variable. So, we applied a classification models. We proposed two phases of the models, like a naive-based classification model, classification method, and another one is a clustering method. Again, with the naive-based clustering plus naive-based classification model. For this modeling, before feeding it to our classification method, classification model, we did a one hot encoding. Obviously, we have to convert our features from categorical to zeros and ones. So that's why we have applied one hot encoding, and then applied to our classification method. And why we are going for this clustering method is because as I already mentioned, our data base system is not a role based. So obviously 2 to 3 users will be executing same set of queries, and they may contain the same pattern, same pattern of execution of the queries. So that can mislead a model from predicting the differentiating between the 2 to 3 roles. So that is why the clustering actually helps us to group up all the similar patterns with the similar roles to one, so that it will be easy for differentiating between the roles as a roles. So in the next slide. So after we have done a modeling by using a naive base and also clustering plus naive base, in the naive base we got accuracy precision recall of around 97.4%. So 97% of accuracy. As we are not comparing our models with accuracy, we are going with the precision recall, because we cannot compare our models with accuracy, because for example, let's take our data set consists of 100 rows, which 80 are true and 20 are false, and our model predicted all 100 as a true. And then when we try to calculate accuracy, it will give 80% accuracy. But here, what our model has done is not a very great thing. It just predicted everything as a true. So what we wanted in our context is, like, we wanted anomaly to detect as anomaly, not as a normal, because that may lead to risks. So a normal query cannot be classified as a normal query. If that happens, just imagine how great risk we are taking. So we cannot go compare with the accuracy. Instead, we are going with the precision recall. And where we let's when you say have seen on the slide, when we compare, it is given 97% from an A base, but 98.7% from our naive base plus clustering. Clustering plus naive base. So we applied a clustering before, and then again classified based on our clusters. Again, we are taking our clusters as our target variable to classify them. So we also, before applying k-means clustering algorithm, we applied a k-means. We consider elbow method to find out which is a priori number of the clusters that we can make to our data set. So we got a 3 as a base. From 3 we can see that the data is going linear. Next slide please. So for testing phase, we are taking again separate data. We actually we have built data on clean normal data, which doesn't consist of any normal and any abnormal or anomaly data. So we in the testing phase, we actually consider wantedly we consider a user with wantedly executed some different unusual queries by the user, which hasn't been done before. So then from then we again tested with our models to see whether if it is detecting them as anomalies or not. From the naive-based classification directly we got at anomalies 10, and from clustering and plus after applying a naive-based classification we got 11. So from this modeling I can conclude if our database system is a role based, then we can just directly go with the naive base, because obviously the role will be considering some set of users to be as a one type, in the sense like all the set of the users who will be on that particular role will be executing same type of queries and with the same type of access levels. So if our database system is not role based, and then we can go with the clustering based classification. We can apply first clustering system, and then k-means or any clustering thing to cluster our users. I mean to group up all the similar users, and then we can apply again classification method with this naive base, and then we can predict it. uh, so next.
So far, we have we have recreated our anomaly detection system by extracting the data and pre-processing and building supervised, unsupervised and classification methods. So as Akhila mentioned, for role-based data, naive Bayesian classification method works well, as we have seen the performance as well. And for non-role based data, clustering unsupervised techniques like k-means clustering, it works well. And so apart from that, we have attempted to integrate our anomaly detector system to PostgreSQL. Because of some intricacies involved in the data, we are unable to achieve it. So as a future work, we would like to work on this issue, and by by using the other techniques like combination of data centric and syntax centric techniques to achieve more performance.
All right, thanks, guys.
Thank you.
Thank you.
I'll show you the demonstration of our project, what we have done so far. This is a poster system which is open source. We just installed it, and we also imported some data, sample database. We created a sample database with some imported data with tables, as we can see here. We also created an extra table for storing our logs. So basically all the logs will be get stored in the back end in the poster system. Let me show where it is. Yeah, over here. So in this data folder, but this cannot be accessed directly. It can only be accessed from the terminal by logging into the poster system. And this is a config file that we edit to get logged in. I have specified to save all the log files in the data log folder, and these are all the log files that are got created from our executions for the different users. And basically it is it is kind of difficult to take out all the CSV files. As I already mentioned, we cannot access directly from the UI, and from the terminal also we couldn't make it. So what we have done is we created a separate table in our Postgres system, this Postgres log, and we have converted these CSV files and pushed all the data into this table. And as you can see the down below, this is the data actually stored in the Postgres. It consists of a lot of information, lot like time it got been executed, and from the which port, its session ID, port ID, and all the information along with the query, and which user and from which application. So these are all and from which actually a lot of information is not necessary. We have taken only the query and the law in the user information, and we have written a sample script to actually pass all the information that what we needed to get our required information, and we applied our models. We have also written from the scratch for the naive and the k-means, as we can see, and we got as these results are already been explained in the presentation. This is the demonstration to show two algorithms which is gonna work for the best for which type of database systems. And as I already concluded, the clustering algorithm works best for the non-role based database systems.